today we're talking about centers of triangles. The first thing we're going to talk about is perpendicular and angle bisector theorems. So the perpendicular bisector theorem states in a plane, if a point lies on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. So here I have CP being my perpendicular bisector of the line AB. It's cutting AB in half, so AP equals PB. This is wrong. This should be AP equals PB. The next one I have is angle bisector theorem. If a point lies on the bisector of an angle, then it's equidistant from the rays of the angle. So AB and AC. So if AD is bisecting angle BAC and DB is perpendicular to AB, and DC is perpendicular to AC, then I'm going to have angle BAD is congruent to angle CAD. So I have the circumcenter theorem. The circumcenter of a triangle is equidistant from the vertices of the triangle. Okay, so I have if PD, PE, and PF are perpendicular bisectors, then AP, BP, and CP, so these three right here, are all going to be congruent. This one's made from the perpendicular bisectors. Okay. So the incenter of a triangle is equidistant from its sides. So in this picture, if AP, BP, and CP are angle bisectors of triangle ABC, then PE, PD, and PF are all going to be congruent. So on the back side, it wants me to solve for x. Because I know that these angles are congruent, I can tell that these two sides are going to be congruent. So I'm going to have 8x minus 27 equals 4x plus 33. And then what do you want me to do first to solve for x? Okay. So then I have 8x equals 4x plus 60. So I get 4x equals 60. And I get x equals... Okay, so 2 tells me P is the circumcenter. AP is 5x minus 3. And PC is 3x plus 7. The final answer should be the length of PB. So, because this is the circumcenter, I know that AP is going to equal PC. So I can set these two equal. So then, what do I want to do first? Add 3, okay. Then I want to do what? So I have 2x equals 10. Divide by 2. I get x equals 5, but that's not what the question was asking for. It was asking for the length of PB, so I need to plug back into one of these two equations because they're all the same. Which one do you want me to pick? The 5x minus 3 or the 3x plus 7? Okay. So I have 5, and then instead of x, I plug in 5 minus 3. Five times 5 is... And then 25 minus 3 is... Okay, so on these next two, because I know this one has the two congruent sides right there, I can tell that these two angles are going to be congruent. So I'm going to have 6x plus 13 equals 16x minus 7. Then what should I do first? Okay, subtract 6x from both sides. I get 13 equals 10x minus 7. So now I have 20 equals 10x. So I get x equals... Okay, and then in the second one, it wants me to find PQ. So again, because I know my two angles are congruent, I can set the two sides equal to each other. Notice, this is exactly the same one as we did before. This time it just wants me to find PQ. So I already know my x equals 15. I just need to plug it into PQ. So what is 8 times 15? Make sure your phones are away. And then 120 minus 27 is 93. So this last one tells me point H is the circumcenter of the triangle BCD. What that tells me is HG, HF, and HE are all right angles. The first thing it wants me to find is CD. So this entire outside length. I know FD is 32. So CF is also going to be 32. CD is the entire length, so I just add the two 32s together. Because circumcenters are made from perpendicular bisectors, the next one wants CE. I know that this CB is cut in half, so if this side is 26, this side also has to be 26. Then I also know circumcenters, the lines that connect the angles are the ones that are congruent. So those three right there. If this one is 33, then HD is also 33. GD is this bottom one right here. So I need to cut that in half if I know the entire length is 58. What is half of 58? 29. Then I'm going to redraw HG. It's this bottom triangle right here. I know that my hypotenuse is 33, because that was HD. And I know that GD was 29. So I need to find this last piece right here. Remember, I can use the Pythagorean theorem, which is a squared plus b squared equals c squared. C is always my hypotenuse. So plugging in, I'm going to make the missing side A, this side B, and the hypotenuse C. So I have a squared plus 29 squared equals 33 squared. What is 29 squared? I got 841, and then 33 squared. I got 1089. Then I want to go ahead and subtract 841 on both sides. So I get 248. And I have to take the square root. So I'm going to do this one on my calculator, which gives me 15.7. Then number 6 is similar. It wants me to find HF, this little tiny piece right here. So I'm going to just copy this over. I know this side is 32, this one is 33, and my right angle was right here. So I'm going to make this A, this B, and this C. So 32 squared is 1024. And 33 squared, we know from before, is 1089. And then I want to subtract the 1024. Which gets me 65. The square root of 65 is, I'm going to round to 8.1. No.